Imagine that you are driving on the road and suddenly your car starts vibrating. What do you think could be the problem? You'll probably say, oh, the tires must have deflated. That's fine. But the problem could have as well come from other parts of the car that help with motion control. There could have been an issue with the brakes, the steering, or even the car engine. So fixing this vibration problem requires that you consider different components of the car and the interactions between them. I'm not standing here today to discuss with us about cars, but about the human brain. What if we're able to apply this type of holistic engineering and system thinking to the brain? I mean, the way we consider the car as a mechanical system, we can also look at the brain as a biological system having interacting parts and processes. My name is Quadri Adewale. I'm a PhD student at McGill University. As an engineer turned neuroscientist, studying the brain from an engineering perspective is what interests me. Did you know that in 6 years' time, 1 in every 6 persons in the world will be aged 60 years and above? That's about 1.4 billion older adults. Yet, many people today are afraid of aging, not because they are moving closer to the grave, but because as you get older, you have a higher chance of developing diseases that make the brain degenerate. We call them degenerative brain diseases. Currently, heart problems are regarded as the leading cause of death in the world, followed by cancers. But according to the World Health Organization, by the year 2040, degenerative brain diseases will overtake cancers to become the second leading cause of death. So you see, there is a scourge that needs to be tackled. I will therefore be sharing this beautiful moment with us today to discuss my research on the 2 most common degenerative brain diseases in the world, which are Alzheimer's disease and Parkinson's disease. But first, let me tell you 2 stories. About a century ago, a woman named Auguste Dieter was brought by her husband into a psychiatric clinic in Germany. Her condition had deteriorated so much that she lost her memory, she became aggressive, and her husband could no longer provide constant care for her. This woman was seen by a very brilliant German psychiatrist by the name Dr. Alois Alzheimer. Unfortunately, Auguste never regained her mental abilities and subsequently, she died. Because Dr. Alzheimer was interested in studying the structures of the brain, he sought to examine the brain of Auguste after her death. As he looked through the microscope, he found that a garbage-like substance had filled the brain of this dead patient. This garbage has a name, and it is amyloid plaques. Some years later, the condition suffered by Auguste was named Alzheimer's disease. My second story dates back to about 200 years ago when an English physician by the name Dr. James Parkinson published a monograph where he described the physical features he observed in 6 patients. He had examined 3 of these patients in his own clinic, and he observed the remaining 3 on the streets of London. All the 6 patients displayed shakiness in one arm, slowness of movement, stooped posture, and difficulty in walking and maintaining balance. The condition suffered by these patients was eventually named Parkinson's disease. Then, some years after, a German neurologist was working on the brain of some patients who had died of Parkinson's disease, and he found an accumulation of garbage in certain parts of the brain. Scientists now call this garbage alpha-synuclein. If I may ask you, What commonality can you observe between the two diseases in these stories? Matthias, your guess is right. The presence of garbage. These garbage are like poisons that cause the cells in the brain to die. And when the brain cells die, patients start showing different symptoms like the memory loss of August Dita many years ago, or the movement problems of those patients on the streets of London. So what could be wrong? Is it that as we get older, the brain starts gathering too much garbage? Or the garbage are produced normally, the brain just can't clear them anymore? Either ways, if we want to cure these diseases or stop their progression, it seems like the natural thing to do is to look for ways to clear this garbage. Isn't that pretty straightforward? I mean, we just need to clear the amyloid plaques in Alzheimer's disease or the alpha-synuclein in Parkinson's disease. And that's exactly what scientists and the pharmaceutical industries have done for many years. They develop drugs to help reduce or clear this garbage. But the sad news is, we still do not have a cure. So what do we do next? Well, scientists probe further and discover that apart from the garbage, there are other culprits involved with these degenerative brain diseases. They observe that the diseases could be associated with problems in our genes, reduction in the amount of blood flowing into the brain, or the brain not having enough sugar, which of course it needs for energy, or even low level of some brain chemicals such as the happy hormone, which scientists call dopamine. Now, can you remember the vibrating car at the beginning of this discussion? In my research, I applied that similar engineering and system thinking approach. Then I consider all this garbage, all these culprits, the garbage, the genes, sugar, blood flow, happy hormone, and then look at how they interact with one another to cause Alzheimer's disease or Parkinson's disease. So how do I do this? First, we obtain brain scans from Alzheimer's and Parkinson's disease patients. So with these scans, we're able to measure what's going on in the brain, such as the amount of garbage that has accumulated, the amount of blood flowing into the brain, or even the level of brain sugar. Simultaneously, we ask these patients some behavioral examinations to examine their mental capacities, their memory, their mood, their movement functions, as well as their daily activities such as exercise and bowel movement. We then repeat these scans at 6 months intervals over a couple of years. Why? So that we can understand how the conditions of these patients change over time. Then I put all these measurements in a mathematical model that I have developed. And this model I program into a software. And with this tool, I made 3 interesting findings. First, I observed that Alzheimer's and Parkinson's patients may have different and multiple treatment needs. So for some patients, we probably need to clear this garbage and increase the amount of blood flow in the brain simultaneously. For other patients, we may have to develop drugs that will help increase the level of sugar and happy hormone. Second, I also found that there are some processes in the body that could help enhance the benefits of physical activity in Parkinson's patients. So scientists, physicians have always known and seen that when Parkinson's patients exercise, the symptoms in some of them tend to alleviate. But we don't fully understand how these improvements occur. So with this model, with my tool, I discovered that the body's cholesterol level and the body's defense system against infections might be important factors that will determine whether a Parkinson's patient will benefit from exercise or not. And lastly, I use my model to identify and suggest a group of drugs that could help treat Parkinson's disease. Interestingly, one of the drugs identified by this model is called levodopa. And levodopa has always been the most effective drug used in clinics to treat Parkinson's patient symptoms. That sounds interesting and promising, isn't it? Hopefully, the efficacies of the other suggested drugs can be verified by testing them in Parkinson's patients. As we move forward, let's remember that vibrating car and embrace the idea that the solutions to many problems around us lie in looking at the bigger picture. Thank you.